Okay, so I'm happy that there are not so many people actually, because this activity is a little bit, it needs a little extra care, because we're going to work with bacteria, with living organisms. So first, I would like to talk about what is the context of working with living organisms, because normally you would need to have a normal biolab for that. And working with a normal biolab, it means that you are certified and that there is an inspector that comes and says, okay, this is approved. There is this part, but there is also the part of the DIY bio, the individuals, the ones that they want to practice and learn basic biology. And you did this with the Biology Zero class a little bit. So you didn't do, but the students of MDEF, they did. And of course, I would like that we refresh some things that you did in this class in terms of understanding how is to create a sterile environment, how is to work with bioorganisms, and what kind of organisms can I work with. So the emergence of biolabs in the Fab Lab network is something that has been for a few years. It's new, let's say, newer than the Fab Labs. The Fab Labs themselves, they are new. They are only 15 years. This is, let's say, 6-7 years. And there are not so many Fab Labs that they have biolabs. But we see the emergence of the need of working more with science and combining this to make the intersection of multidisciplinarity. And we have some labs that they start, whether they are in the universities, they can start and have access to formal biolabs. Normally in biolabs, when you would have ultraviolet disinfection light, so when you go out, you turn this light with a timer, it disinfects everything, and then you cannot go directly in because this is hazardous for your body. And then you would leave 15 minutes and then you would enter, no? And there are different types of disinfecting. Also, there are curtains, disinfection curtains, so you can enter and with your coat. The thing is that in this activity, we will not be able to talk, because if you talk, you will contaminate, even if you have the mask. You would need to have your hair up, and you will need to be cleaning your hands continuously. Cleaning your hands before the activity, cleaning your hands while the activity, cleaning your hands after the activity, washing. So this is a little bit like level 2 in terms of working in a sterile environment. What we will do is that we will create the DIY sterile environment. So there are different types of sterility. What we're going to do is that we're going to work with a Bunsen burner and create a bubble of sterility by making an alcohol circle around it. And this is how you can make the transfer. So the other thing is that the type of bacteria that we can work in a DIY bio in lab, like that is more, you know, like not official, is biosafety level 1, BSL 1. So these are no pathogens. You cannot work in your house. This you can do it in your house as well. The activity that we are going to do now, you can do it in your house. But you need to be sure that you're working with BSL 1, biosafety level 1, and not others. If you want to work with others, you need to have access to a proper biolab equipment. Okay, so the activity that we are going to do is part of the Fabricademy Textile Academy curricula. It is under the activity of learning where the colors come from. So where does red come from? Do you know? Where does blue come from? Does anyone know? Where does black come from? Yellow, like any color. Do you know where this comes from?
is blue coming from, I know it. It's how to say it in English. Brass? No, wait.
Yeah, you can definitely make colors with metals. Like you can oxide metals to get colors.
Sorry, copper, like
yeah,
copper
get
crystal.
copper. So the thing is that this is something that we want to raise awareness also with this activity, is that in 1894, where the chemical dyes, the chemical colors, the chemical compositions were invented, everyone forgot where colors were coming from. Actually, for 2000 and more of years of the human history, we have been very, very rich in colors. And now, with chemical dyes, only the 100 last years, nobody can answer where colors come from. So I will talk about a color called Cochineal. It's a bag in Latin America that it brings, it gives you the red color. I will talk about Indigo, which is a plant in Japan and in India that brings the blue color. Curcuma, that is the yellow and orange color. Anato, mother root, bark, hibiscus. All of these were we were using plants, roots, and even food waste to create colors. And you can create colors for dyeing, you can create inks for painting, you can create pastels by using thickeners, you can create anything, any kind, like pigments, powders, inks, pastels, all of the different types. No? And within the Fabricademy, the Textile Academy, we have this assignment is using both the bio-zero knowledge and the pigment and color extraction from natural dyes. We are going to do only the bio part today. We're not going to do the natural dyes today. We're not only going to do the bacterial dyes. But it's a very good question, no? Like why we are like so far away from knowing what can nature give us, since we have seen in the caves of O.G. the Iceman paintings that they were red and black, and how did they do it? Like, also, like if you think about it, how they were, the Incas, how they were moving these stones, why did we lose all this knowledge? So, yes, we have a moment in life where we synthetically, chemically create colors, and after that we forgot about our history, which is something that we want to bring awareness. Especially the color blue is the most difficult color to find in nature. And this was also the problem, because the painters, they wanted to paint the sky. So you have like Rembrandt and like all of these different artists that they want to represent the sky, and they don't have the color to do it. So this, when the indigo and the blue came out, it was very big, let's say, technological advance. So we use chemical dyes and for everything nowadays. So you can have your big pen, which is something that everyone has. This is a chemical composition. All of the clothes that you wear, they have been dyed with chemical dyes. This has some advantages because it is always the same. So you can make mass production and then you don't have any color variation. It is staying a lot, doesn't fade out with the washing, but at the same time, it has many disadvantages, which is basically that in order to do the chemical dyes, you use a lot of chemicals that you dispose afterwards in the water, and this contaminates all the drinkable water of the planet. So basically, the chemical dyes are, and the textile industry is the second most polluting industry in terms of water contamination on Earth. And of course, we cannot say that there is not an intention of improving, like that they will gather this color and the chemicals and they will densify and they will make like powder out of it. So they do many processes in order to not to do less harm, but still there could be other alternatives to chemical dyes. And with the let's say, with the society nowadays that we are more and more working with with microorganisms and biology, the science that we can bring in the production methods, in the production processes, is coming all into synthetic biology. So we see synthetic biology in culinary. Now you can eat a burger that has been done from, it has no meat. So this is all synthetic biology. You can do the molecular gastronomy. So we see that there are a lot of processes that they are nowadays based on processes of molecular, microbiology. And in this case, we are going to investigate how we can extract pigment from microorganisms. So there are different microorganisms that they are productive, and they produce color. Think about, for example, do you know where silk comes from? From worms. So there are these little silkworms that they, like the spider, no? The spider web. So it's the same. Instead of having a worm that you can see, you have a microorganism that is producing pigment. And yes, so we are going to do the basic workflow of striking a petri dish and inoculating bacteria. And we are also going to combine it with ancient tie-dye shibori techniques. I will show some video where you can fold fabric in specific ways so that you can make different patterns in colors. So the activity is two parts. One is the understanding how to inoculate and creating a sterile environment. And the second part is understanding how I can make folding techniques based on the Japanese shibori so that you can make different patterns of colors. Then, when we talk about color, we need to talk about color fastness. Color fastness is how long will this color live? No? How is it going to be washed out in one wash, or is it going to stay? So the bacterial pigments, they are the same as natural dyes. They are not the same as chemical dyes. They will fade out with time, but not in the first wash. No, they need like a cycle of washes, so they fade out. Yeah, they fade out in time. So, so I will change now to this camera. Yeah. Whoop. Yes. And what I need first, so I need to tie my hair up. And this is important, huh? Like all of these first steps. Put the lab coat. Put the mask. Also goggles if possible. And here you can have you have the I don't know. I like it like that. So. Okay, so in your on your desk you have And if you don't have, let me know if you want. You have two flyers. One is the flyer, which is step number 1, and it is the bacterial preparation. You have only the 2? Yeah, these are to share. Huh? So you will open and you will see the safety instructions. So wash your hands, use personal protective equipment, work only with biosafety level 1, sterilize your working area, and don't touch your face, don't touch your face, don't touch your eyes, and pull your hair back. So this is important. We will do first the step 1, and here you can see all the materials and tools that you need for that, and all the steps. And then afterwards, we will do the step 2, which is the textile dyeing. What I will do is that I will show you the step 1, and then if some of you want to come and do it with me here, and then the textile dyeing, you can do it on the tables, okay? So first thing is that I need to be clean. Then I need to clean all of the table very well. Gracias. And this is DIY sterilization. You can work with mushroom like that. Alcohol. Yeah, I should be using the other alcohol, but I'm using hydrosol. I should be using the 90%. Pure alcohol. So now we have, I want to show you the bacteria first. So you can plug the pressure cooker. And then make sure that your sleeves, they don't go down. So it's better that you clean your hand up to here. There is something in the pressure cooker. There are all the... So first I will show you the bacteria, the materials. Franzi, she made the flyers. They're super nice. So let's see the bacteria first. So we have, it smells very bad. We have the Xanthinobacterium lividum that produces violacine pigment, purple. And here you can see two petri dishes, one small and one bigger. And you can see that this one is darker than this one. So what happens? When the pigment is not very intense, it's because there is too much heat in the incubator. So it didn't produce pigment. You can also see that here, I'm writing down the date, the type of the bacteria, and my name. I didn't write my name because it was only me that was doing all of this. But you will need to write in the petri dishes the name. And here you can see that we have this film that is called parafilm. That is a film that breathes out, but not breathes in. So it's a very smart material. Yeah. So I will show you the bacteria. I hope that they are in a good state. So again, yeah, they're not in a very good state. state, actually. They're not in a very good state.
I don't know.
Let me check which one. So, amazing. So look at this. It's crazy. So I had different Petri dishes, and I was taking from different Petri dishes. I put these two in the same day. Look at this one, how it grew, and look at the other one. So I will continue extracting pigment from the good one. This I will kill it. I don't want it. It doesn't give me anything. So it's like the selection, because you are taking the good cells. Basically what you're doing is that you are trying to take single cells. Okay? So let's see the material. 24 degrees. So where is the flyer? Step one. Give me that. No, first this. Okay, so a little bit of technical equipment to understand what are the tools that we need in a biolab. First of all, we need to have the camping gas, to have the lighter. We need to have Petri dishes in different sizes. Oh, that they close? It's okay, it's okay. Now this we will need to clean them with alcohol. You need to have an inoculation loop. So I'm using all the tools that I'm using. They are metal or glass. This means that I can reuse them. I can sterilize them and reuse them. Most of the times, when we will be doing this big activity, I would give you a single-use plastic inoculation loop. I don't do that because then there is a lot of waste. But in many cases, you have plastic tools that they are sterilized in and wrapped. You open them, you use them, and you throw them. I use glass and metal, okay? So we have the inoculation loop. We have the parafilm, which is the film that we put around the Petri dish to close it. Then we have the pipette. There is no pipette. It's okay. We have the Bunsen burner. We have the incubator. So this is a reptile incubator, very, very cheap. It's the one for making the reptile eggs. So this is the least expensive one. 100 euros something, because if you go to lab equipment, biolab equipment, an incubator would cost like 3,000. So this is the hack, no? And you know there is the Biohack Academy that they also run in the WAG, that they have all the DIY bio machines that you need to do. So all the machines that you need in a biolab in a fab way. So then you have this is a reagent bottle. So this bottle, it has this blue lid and it can be pressure cooked, and this plastic will not melt. So it's a very specific bottle for being able to sterilize the medium that is inside, that we call the medium, which is the food of the bacteria. It's called the medium, and I need to open it. So then we have the different mediums. So this is nutrient agar, and the recipe is on the instruction kit. So you need nutrient agar with glycerin and distilled water. It will come now. And this is the first medium for making the inoculation, which is transferring from one plate to the other. It's called inoculation. And then you have the LB broth, okay, which is the liquid medium that you soak the fabric in, and then the bacteria starts to feed from that. So we have two types of mediums. One is the solid. It's like a jelly. It will create a jelly in the Petri dish, and then after we will put the bacteria. And the other is liquid. We will soak the fabric in, so then the bacteria can start eating from that. Then safety equipment. You need also a permanent marker that was here. I saw it before. It's there. So you need a permanent marker because you want to put the names of the names of you and the type of the strain and the type and the date. This is the color that I have been extracting from different Petri dishes. So this is the bacteria that has methanol inside. The bacteria is dead, and then you can use it as ink. So I have been, every time that I am harvesting the color, I'm adding it here. This is like 4 or 5 Petri dishes with ethanol only. Questions?
So when you add the bacteria, you add ethanol.
So that's the killing then after. So first we need to create the sterile environment. Then we take out the bacteria. Then first we basically sterilize all of our tools. Then we create the sterile environment. Then we take out the bacteria. Then we transfer straight, it's called strake, the bacteria from one plate to the other. And then the old bacteria, we put it there and we pressure cook it and we kill it. There are 2 ways to kill the bacteria. One is to pressure cook and the other is to with alcohol. But it's better to pressure cook. Basically, you do both. You pressure cook and alcohol. But then here, when I harvest the bacteria, it's only the methanol and the bacteria directly. I don't think I can pressure cook that actually. The distilled water.
Where is it?
San que tenemos agua destilada ahí atrás en la laza.
Ahora te busco.
Ajá.
No idea. No idea.
You put, okay, so first step is to sterilize everything. And one thing that I forgot to show you, which is very important, is the autoclave bag. So this bag, again, it is able to breathe in and not breathe out. It doesn't melt in the pressure cooker. So when you sterilize, you don't want the water to come in your Petri dishes. You put everything in the bag and the bag in the pressure cooker. So there is water around that can become steam, but then still the Petri dishes, they are clean inside. So, yes. So these Petri dishes have been sterilized. And there is like a hole. Yeah, perfecto. Yes. You don't need, but you need to clean the Petri with alcohol, and then I will prepare the medium.
Anastasia, where does purple came before?
It's the purple blue.
That's like, was very difficult. That's why it was difficult for royalty.
Exactly, yes. There is a fish shell that was making this purple blue. There is the indigo that is blue, and you can, because now I cannot take my mask out, because you have the color, But then you have the modifiers. So you can change the pH, which is acidic or alkaline, and you can move in the color range by changing this pH. There are things and bacteria and natural dyes that they are reacting to color of pH, and there are others that they don't. So if I have made onion skin brown, I can add lemon to make it more acidic, or soda, bicarbonate soda, to make it more alkaline. So these are called modifiers, and you have different kinds of modifiers. And you can work with lemon to make it more acidic. You can work with bicarbonate soda to make it more alkaline, or you can work with iron, copper, all of the metals, they are modifiers. So that's why you can have the whole gamma of the colors. For example, if you don't have a pH reader, which shows you, like, if you put, you know, this thing that you put in your tongue and it says if you are sick because you are more acidic or more alkaline, that changes the color. If you don't have a pH reader, you can always use a red cabbage, because the red cabbage will give you all the range of colors. It has all, it can be, with all the modifiers, you can get all the colors with a red cabbage. So you can make it from pink to black, you know, like from yellow to black, by adding like the different modifiers. So red cabbage, you can use it as a pH reader. So,
Which camera?
no, no, I will make the medium. So in the beginning, I can make the medium.
We need the other one.
Yeah, I will keep on cleaning that one.
Hold on. This one is clean. Where do I put the ones that are clean? Should we use a new bag, or those are clean?
Yeah, we will use the new bag. Yeah. So these has they have been pressure cooked. So there is no issue with only like residues. And if someone wants to come and help me clean them, there are many. So you wear the lab coat, you wear the mask, you wear the gloves. Yeah, there are many different sizes of lab coats. I'm not sure. And then, so one other, yeah, you put the gloves, yeah, after. Okay. Yeah, and then it's too small?
I think so. Nosotros.
Tenemos otras, ¿sí? Sí.
And now we gotta clean them again? Or?
Yes, now you can put alcohol again and take this, put it with alcohol.
Cool.
And then put alcohol in the Petri. So while we are doing this, someone can take this sheet from there and you can cut. So what we're going to do is that we're going to do a long, let's say, scarf. Thanks. It's a lot of exercise, morning exercise, up and down,
Up and down.
up and down. Yeah, the alcohol. And you can cut in the width like this. Yeah, and the length is kind of like, I think, the length of the material. Let's see. If that scissor is not working so well, let me know if we need to bring another one. So this one is quite dirty.
Do they have a scissor though?
Eh?
Do they have one? A scissor?
The scissor is there. So this is dead, but the color stayed. And you need more alcohol, probably.
What is it with the bag?
My bag here. My bag. Yeah. You didn't find it? No? It must be here. Let's see, which one are you making? Let's see. Let me see. Yeah? No. Yeah, that's perfect. Here. Let's see.
Las cosas que pasan.
And we can make how many people want to do the activity. Okay.
The water is fine, right?
You can add a little bit of the distilled water.
Okay.
Muchas cámaras.
Maybe you can show, someone can show to the camera how to.
After, now they are only preparing. Because there are people online?
Few of them, 5, I think.
Oh, yeah. But they can run to come and do the activity. No?
From Croatia,
Yeah, it's a little bit difficult.
Take a flight, come on.
Because it's Roberto. But Roberto is going to be Fabricademy next year.
Really?
We have been trying 3 years to do it.
If you want to move this thing there, the camera will show.
Yeah, we will. We will not. We will not. We just clean now, and then after, when we move in the next step, we will
I think it's okay that
explain.
the people see what's happening on the table. It's not.
Now we are only cleaning and cutting the.
Right?
Yeah, we will put everything in the autoclave bag in the end. So you can take this out and then start putting the garbage in. More good.
Put the autoclave bag in already.
Yeah. So now, once we will finish with the cleaning, we will prepare the meeting. So we need try to open this. Finito?
Can we use that still?
Yes, we can. We can How much can we put more? Like, or we don't?
Take about 100.
No, just then we will just autoclave as it is.
So I will put that in already.
But we didn't have more of these, no? No.
I can go and
No.
look through the of what I saw.
How clean is clean?
So we autoclave this one, right?
Yeah, I will put everything with the, when everybody's finished, I will just show it. So let's wait.
Are there any more to clean?
These ones. These,
Okay, meanwhile, I'll go up and I'll check again. What else is there we might need?
the pipette.
I didn't find a pipette. The only thing I found is this and
Yeah.
this. There's no,
Okay.
like, is there any hidden cover that?
No. The pipettes, they
on the
are,
right side, right?
they are here.
I'll go check.
But don't go, it's fine, it's fine. We don't need anything. No, don't go, you will just lose the time. Okay, let's try to make sure that everything is clean. Well, difficult. So, how many do we need?
Yeah, one more. Possible?
Yeah, it is also depending on the number of Tetris we have. So we'll see. Cut one for each.
That's
So,
the only clean?
yeah.
Is this clean enough or?
Yeah.
Yeah.
They're clearer than mine. Yeah, this is perfect. So this one.
Sacándole brillo.
Dándole con todo.
Like a phone cleaning the dishes.
We are ready? Yeah? Okay, we have been cleaning the Petri dishes that have been sterilized before. It's okay. So let's see if we can move forward. Okay, perfect.
This one.
This one before, but I think it got mixed with the dirty ones.
Ah, they are not so clean, but yeah. No. Yeah. Okay, okay, go. Perfect. This one will work. Perfect. Okay. No. One, two. 4, 5, 6, 7, 8, 9, 10. Okay. So this is not very good, but anyway.
I throw the bag already?
Shall we continue?
Yes.
So the first thing that I need to do is to prepare the medium, which is the food of the bacteria. And this, since I'm going to sterilize it, I don't need to do it in a under the Bunsen burner. I can just do it in dirty, because after I'm going to pressure cook it. So I need the reagent bottle. You can go back to this.
Yeah.
You swap the camera. And I need, according to the recipe on the manual of the first part, I need 200 ml of distilled water. Yeah. I need, sorry, I will do the recipe of the second manual, because I will do directly the liquid medium, which is for the dyes of the textile. I will not, I will do afterwards, I will inoculate new Petri dishes, because now we want to dye the fabric. So I will do the 250 ml of distilled water. Then I need the digital scale to put the LB broth, which is, I turn it on. I zero it. So I zero it with the cap on. And then I need 6.75 grams of LB broth. So this is caldo, this is broth. This is like soup. It is, you can, if you don't want to buy the expensive bio food, you can make it with the rest of the chicken soup. You know, you can also do that. So 6 point.
So that one is made of chicken? Or?
Yeah, I'm not 100% sure what it has, but yeah. Yeah, it's perfect. It's like 6.8, this. But the thing is that it has been, yeah. So it has been petrified because of the humidity. So I need to break it before I put it in the mix. And we need 1 ml of glycerin. And this, you would normally need a pipette tool, which is like a small bubble that takes out with millimetric. But since we don't have a pipette, we are going to use a normal syringe for measuring the 1 ml. So now we try to break everything. Doesn't make any sense to do it here anymore. Yeah. There we can add it. You can go, for example, online, and you will see what is the composition of each medium. And also, like if you go to Japanese forums, they have completely different mediums. And 1 ml of glycerin.
The other one wasn't used.
Yeah. Ooh.
Like the other one.
Yeah, I can use this one.
Oh, I mean, the other one.
Ah,
This one should work.
but I can still use this one. With you, I have the. This is for transferring the bacteria, so it gives me the 1 ml measurement here. Okay. And yeah. And now it's not this cup. It's this cup. I put all the cups wrong.
After sterilizing everything.
And now, no, now we will sterilize. Gently mix. I don't know how gentle is that, but
Shall I continue mixing?
the thing is that it needs to, like, really, normally in the bio lab, you have this moving table, you know, that continuously mixes the thing for a long time. We don't have that.
So it's gently mixing.
This thing that does this. Yeah, okay. Okay, so very important, we have closed it, we have mixed it. It's not perfect with the distilled water and the glycerin. Now we need to unscrew the cap, and with the cap unscrewed, we place it in the pressure cooker. The same for this one. So that's how the sterilization happens, because the steam can enter from the cup. Very important that you have the bag, you have water around in the pressure cooker. The bag protects the things from getting wet, and these need to be vertically placed, because if they are like this, all the medium will fall out. So this is kind of tricky, because this pressure cooker is small and I cannot put bigger bottles, but there are other pressure cookers that you can put even bigger reagent bottles. So now we have these open, and since we are going to do the activity now with the textiles, we can close and pressure cook. So yeah, this is a little bit like longer.
So are those packs just like for one, or you can reuse?
I have been reusing them. Yeah.
This is just because it's a bit big, the bag.
This bag is a little bit big. It needs to be closed, but not hermetically closed. So you just do like this, but you don't try to close the bag completely. No, I buy this here in the PB's Cat. It's on the corner. It's a bio equipment place. Yeah. So now the fun part. What we are going to do while this is being pressure cooked. Yeah, it has like, yeah. So we can like, So this closed and we can put it 20 minutes. So this is going to start building up the pressure. It's a normal pressure cooker. It's going to start building up the steam pressure. It's hermetically closed. When it has built up the pressure, it will start counting down the 20 minutes. And when it's done, we will release the steam and everything will be sterile. While this is happening, we will do the activity for the textile folding. So now I can take out my gloves, and it's very important to learn how to take out the gloves. So the glove needs to go inside out. You need to take out from the other direction. Yeah, okay. And I will give you. So what we are going to do is that we are going to learn how to fold in different types. I will show you a video. And then you will place your textile inside the Petri dish, and we will pressure cook the Petri with the textile afterwards, so that we will sterilize our fabrics. There are other ways to do it. If you want, you prepare your fabric. I sterilize everything now, and then we just take out the fabric and place it in the Petri dishes. So there are many ways to go with that, especially if you are using plastic Petri dishes that you cannot sterilize many times. What we are going to do is that we are going to prepare the fabric, place it in the Petri dish, and after sterilize everything. So we have different sizes of Petri dishes. It's luck. How many people we are. What we need to do is that you need to make sure that the Petri can be flowed. So you fold so that the height is there. It should not, again, you can touch everything, there's nothing there now. Everything is okay. Yes, we can also place two fabrics, but then somebody will like to have the other. Because sometimes it will, sometimes when you place two, all of the material will only one. Okay, how many people are yeah, there is sometimes I also do this. I will show you like a little thing that I do. If I want to have a bigger height, sometimes I take two Petris and I place them like that. But this is a little like, it's not very conventional. But if I want to have double the height, I do it like that. Yeah?
So are you going to show the video?
The video of?
How they fold it?
Yes, I will show you now the video while you will be receiving your a Petri. I think there is one extra Petri there. I will show you the video while this is building up. Another Petri dish. So you got the like this. we will do like that, okay, for you? Okay, let's see. I will, okay, no,
Yeah, verás.
yeah,
Haces share screen, ¿verdad?
I will, yeah.
A ver si lo logramos hacer bien.
Thread upstairs, right? We need
Yes, here.
thread. I'll get it.
Sorry. I will share my screen.
¿Vale?
Give me a second. It's my kind of like horrible, my desktop, everything. Anyway. Share. So, sounds. Not sure if the sound of that. Okay, not sure how well you can see. There are many ways to install. We have some rubber band. This is an easy basically or the other direction. I will put more videos. They're coming out very nice. Let's see. Yeah, so you can make different like square pattern. It's like a very arbitrary. No, I don't like that so much. Like, so make sure that the font is very tall so that so let's see other video. So maybe this one is better. Yeah, we'll put the full screen. Oh. Okay, now I need my. Yes.
un germán va regalar un dinar
Hi everyone! In this video, we're trying out the fun Japanese fabric dyeing technique called Chamori. You'll need a tablecloth to protect your workspace, and if possible, this is a great project to do outside. You'll need fabric or clothing to dye. It's super important that you choose fabric that has cotton in it. The higher the percentage, the better. That will give you the most vibrant color. You'll need a bucket or other.
formar part del club d'aquells que vaig dir tenen una associació d'armatat així que es troben per el tio està no sé com no hem trobat un plat tipus hay un hueco para salir. Oye, a ver, venga, vamos a liquidar. ¿Qué vamos a hacer? Vale. Llavors, a cada slide, quina informació podem posar? Vamos a hacer Calen, això no ho tenim, això no és com... No. Quines metodologies?
¿Ya se te pasa?
Sí, ese y luego poner acá, poner acá, porque los blancos, eso, y luego va a llegar el color. Entonces se va a hacer cada cuánto. Y ahora hay como alguien online, ¿no?
¿Eh?
¿Hay alguien online? Okay.
No lo veo.
Sí. ¿Quieres irlo?
¿Qué hora es?
La 1:30. Vas mal. ¿No?
Voy mal, ¿no?
No sé cuánto te falta.
Voy mal. Ok.
Son 3 o hacer esto posar per
ya está.
Aquí ya.
Tenemos, bueno, tenemos tiempo, pero luego creo que la actividad va a pasar un poco las dos que supuestamente, ¿no? Ya, ok, voy a terminar esto. No, mira, this one is also nice, but makes like a little less. Yeah.
Llavors aquí
With the rubber band, then band is super nice.
el tema de les microchannels. Algo de... No, només explicaria el de... Jo, sí, que en realitat era... Per un tema d'un mes, sí, una cosa és no un mes, un trimestre i no setmana, talent. Bueno, ara els challenges són 3, sí, són 3 setmanes, un mes, sí, perdona, perquè hi ha el contingut i després l'apliquen, sí, sí, un mes. Vale, vale. Perfecte, ja està. Doncs per ordre seria una setmana, veritat? Ender, que és un mes, diguem, on hi ha unes classes o un tòpic cada setmana amb una classe maestra. Després el tuit, que és un acompanyament, no? Perquè això, bàsicament, va ser un acompanyament del challenge. És molt similar a... Cuando con la luz... És més així, no? Bueno, no. Jo tinc, el dubte tinc, perquè mi tot, no? Clar, nosaltres com si vam prendre tot el protagonisme, no? O sigui, no fa que ho diguem, això. Però sí que és veritat que no era una companyia. Era bàsicament, vam dir de contingut 3 mesos. En canvi, per exemple, amb Jugando con la Luz o a The Big School, hi ha un objectiu, o sigui, hi ha una premissa allà, no? Però després, com es gestiona tot, com siguéssim, nosaltres només hi ha una part d'acompanyament, però hi ha una part que ens carreguem a l'esquena. Crec que és més el que passarà si proposem una cosa a long term. És com... Hi ha unes sessions inicials, saps? Però després, com siguéssim, si hi ha un acompanyament mensual o alguna cosa així, saps? O setmanal, no és que nosaltres arribem a classe i anem al contingut, saps? Saps què vull dir? Vale. Doncs llavors, llavors aquí no explicarem el contingut de cada d'ells. Espera, deixa'm-ho posar aquí. A veure, per gratuït tenim perfectament. Per MDF no, però tinc molt similar, una setmana i tot això. Sí, però vull dir, sí, però tenim els... Sí. I de Mid-Talent, què diem? Que és una setmana o que són 2 dies? Llavors aquí hi ha, a part de la descripció, hi ha una descripció. La metodologia què vol dir?
Before, I was ready to wash
Essencial, no?
this silk at home. And this is why, because whenever you buy any fabric or any clothes that you wear, your new clothes, they have a finishing, wax finishing, so that they can travel around the world without getting stained and without being fatigue. So when you buy fabrics, they come, the new fabrics in the store, they come with this finishing. There's scanning coating, anti-net base, or wax base. So I have previously washed this fabric to take out this finishing, because otherwise it will not absorb the bacteria. This, in the textile dyeing processes, is called scoring. So basically you wash with the pH neutral soap so that you take the fats and all the wax.
Llavors, a la descripció hem de quina edat, quanta gent va participar. Això com ho fem? O no ho vols posar? Posar contingut o no? Bueno, està el disseny, està el que es fa en cada sessió. No. És que skills i competències ens guiarem. Perquè jo crec que això ho posem al principi. Hem d'explicar quins són els, com es diu, l'ecosistema. Però això potser ho hem de posar. O sigui, depèn de qui són els elements, no? Professors, aquesta organització de fora, saps? Aquesta, saps què vull dir? Avui teníem a MDF, Talent, hi havia FD, nosaltres, el que sí que MDF, no, però perquè...
Okay, we have, when you finish, you put in your pantry. Now, next step is that you put the date. You put the
menys la part on neix fan el xat. Les classes són híbrides. Sí, inclou-lo, perquè remix de school, què seria?
The bacteria will take 2 to 3 days to grow. So now you put the strength, the date, and your name. como cada...
Llavors, hi ha un que fa de posar un quart. No. Sí,
The hippie. The hippie style. Okay, we'll stop sharing. Si quieres ponle la... Ah, nada.
¿Aún? Ya, ho he vist.
Okay, each of the ones, so we don't forget.
Wait.
Diego and me. Yeah.
L'impacte que estem fent.
Now, then we have the Clement. Yeah. Ah, yeah? Okay, cool. Okay. So there are two ways we could put only the textile in the pressure cooker. If we have the plastic packaging, because the plastic packaging you cannot pressure cook. So what we do is that you have the bag of the you pressure cook the fabric alone, and then with the metallic tweezer,
First person perspective.
since we have the glass petri dishes, we will put them directly with the petri inside there. So one other thing is, so now we are making the liquid medium, the LB broth, which is so that we can soak the fabric and then inoculate the bacteria on the fabric. One thing that I want you to see before is that, yeah, how we so okay. Okay, so this is the bacteria, and it is on the agar medium. The agar medium, the nutrient agar, is the jelly. The LB broth is the liquid. The LB broth is for the fabric because we don't want the jelly to jellify on the fabric. When we inoculate, which is transferred from one plate to the other, and we place in the incubator on the 24 degrees that we want for 2 days so that it grows, we need to put the petris upside down. You see? The bacteria up. This is important because any kind of like bacteria other that wants to come and go inside, it cannot go from the bottom. So you need to place always the petris upside down in this case. In this case, you cannot because there is liquid. So you need to use a paraffin. So the bacteria, so we need 10 more minutes. So let's wait for the others to finish. And what we can do is that, okay, so this doesn't have a date. It's very bad.
What? Yeah.
So these are from Friday.
Sí,
Yeah.
sí, huele raro.
So this grew a lot from, so, yeah. This is the liquid. Yeah.
Mira las cámaras cómo están, ¿eh? Lo digo por si quieres que te ponga la...
No, no, it's fine, fine. Okay. Okay. And then we have some that they even grew at all. Okay. So, 9 more minutes. The process is we take out the medium, so we let it cool down. And then as soon as we take out the medium and it cools down, we put this to inoculate. So the process now is wait. So I don't know if you want to, we just put the, what?
To buy your break.
To bio break, yeah. To bio eat something maybe. Because basically it's waiting 8 minutes to take this out so that it cools down while we're putting this to sterilize for 20 minutes.
Okay.
So this is the problem with this activity, that it has 2 steps that they are very long. Yes. And this one also. Yeah. What is your name? Liz.
Well, those were my initials. There's only one.
Okay.
You want my full name?
No, it's fine. Okay.
No, I wanted to order.
Tell me, who is going to come after half an hour to do the inoculation? Everybody? It's fine? You are good to go have a lunch break and then come? Yeah? We do it like that? Because this will take, yeah. What time is it now? 1:45. So we meet back here at 2:20, 2:30? Sounds good? Is it good?
Yeah.
Yeah?
What is it gonna be, the next part?
The next part is to take the bacteria and put it in the, which is the good part. It's the part. Yeah. Because now we are sterilizing the LB broth, then it needs to cool down. Now after we sterilize this, and then after we create the sterile bubble with the Bunsen burner and we inoculate the bacteria. So is there somebody that's not going to come after the 2:30? It will be quick, huh?
I have a class at 2:30, but when she can.
Yeah? Okay.
I have a meeting at 3, so
It's good. It's good because it needs to be quick afterwards.
okay.
You need to work very quickly, open, close, and
But we just need to wait 5 minutes, or we need to calm down and...
we need to wait 5 minutes to take out the medium that we have been sterilizing and to put this for 20 minutes inside.
And meanwhile, the medium is cooling down.
Okay.
So that's why we did the 2 steps.
Okay, we see each other at 2:20, 2:30. Well, you can stop the recording. Ah, wait.
Doesn't quite fit.
Ah. Yeah. Maybe we put it. Okay.
Or could we put two, like he says, two like this?
And then each of the bacteria, they have different incubation time. You can even harvest the bacteria. I don't know what you did in MDET in the beginning with from your saliva.
Yeah, yeah. With the
With a stick.
yeah.
You will. Okay, next. And this. Yeah, next. So this one.
And then we need to close them and flip them, right?
Yes, we will close them with parafilm. So that would be the last step. Yeah, you put the film? Yeah. Yeah. Yes, you can cut this side. It's very thin. Yeah. So, yeah. On the side, you don't open so much. Yeah, and then quickly on the down part. Yeah. Close. Backfire. Yeah, this is normal. It first builds up the steam pressure, and once it builds up the steam pressure, then after it. You mean it's not very close, or what?
I don't know, because it's making weird noises.
Yeah, it's good. Oh. Back to the fire. Back to the fire.
It's just cool.
Yeah, this is what happens. So, scissors. This happens with this. And back to the fire. Very. This will go inside. After you push it a little bit too. Yeah.
Anastasia, like this is fine?
Yeah, these are fine. Push it all inside. Close. And back to the fire. Okay, do this for like 4 or 5 times. Okay, perfect. So, perfect. Is somebody else missing? Yeah, okay, please. So what we will do afterwards, I put the bacteria to prepare it for the workshop on Friday. So what the bacteria doesn't live long, it lives 4 days, 5 days. So what I need to do is that I need to prepare new plates with agar, that is the jelly, the solid, brand new plate, and do the striping to inoculate new plates so that I can keep the bacteria growing continuously. And I need to do this process approximately every 4 days, 2, 3, 4 days, max 4 days. And this is how you keep the bacteria alive. If you want to stop the process, because you don't want to do more inoculation, you would need to freeze the bacteria. And this you would do where's the little yeah. You would put glycerin in a sterile thing that I don't remember what's the name of this, sorry. And then you would extract bacteria, put them in the glycerin, shake them, and put them in the freezer. Normally, you need a special freezer that they go -80 degrees. But we will try to put them in this freezer, in the normal freezer, and then after a month, I will try to revive them to see if they live. Otherwise, I have bacteria in the center of genomics that I already gave to them, and they keep them in their fridge. Every time I need, they wake up some bacteria. So I'm collaborating with the biology university so that they can keep my bacteria that I buy from a center that they sell the bacteria. You can also harvest these bacteria in nature, but you need to know. You can go in the nature and know how to, so that then after you extract, you strike again and again and again until you get the purple, and then you take the purple and you put it in a new plate, because what you want is to isolate the cell. There are many different cells in nature, and what you want is to isolate one cell. Okay? Yeah? Okay. Now after, wash also your hands with the soap and water. What is missing? There, that one, huh? Take this, I will bring that. Opa, this one is a little problematic, yes. Yeah, we also need to prepare agar medium.
For the new place? Okay.
Yeah.
Can I do that in the same one, or do I have to?
Yeah, you can do it in the same, it's
Do I
fine.
have to wash it?
No. Very good. And try, yes, to make lines. And then close and back.
But it's just like I was thinking just the wheel is like what, like 60? Wheel is 70. So at this one is 120. I have like 25 or 25. Maybe I.
Can you hand not the pipette thing?
This? Yeah, you have it, you're good.
Yeah.
You've done it before?
No, never.
Like you want to.
Yes, you can even try like, yeah.
I was thinking this.
Hit the knot?
Yeah. Okay, and the alcohol. We're done? I will put a little bit more there. I will fix them now. But we're done. And then on Thursday, do you want to fix an hour better to say, okay, on Thursday at 11 we...
Would be for us, yeah, for us to be better on the afternoon because we have this dialogue.
Ah, yeah, okay. Yeah, okay.
We have, Web Academy has classes in the morning.
Okay, then in the afternoon, I will just try to find you, and if I don't find you, I will bring all the things there. Okay? Cool?
Do you need help to close the...
No, I will finish this now. I will fix a little bit. I will just put here a little bit
Like
more.
my art teacher, you know, like when I went back to my paint was like, wow. She fixed it, yeah, every time, like, so my parents will think I'm an artist. And not only they say like, she's working, like, she's such a nice teacher.
Nice, huh?
Yes, so much fun. I was really nervous at first, but then when I did it, I was calm, really.
Yeah. It's nice.
Yeah.
Let's hope that, yeah.
They grow.
Let's hope that they will grow.
Let's hope that the bacteria like us.
Yeah.
Use a happy purple.
In general, all the processes, the growing processes, and making, they're slow, you know. Let's hope that they will become very purple.
Good, thank you.
You like it?
Yeah, really, a lot.
But the idea is like that you understand also like how to create the sterile environment. Yeah, and all of these things, no?
Thank you, Anastasia.
Thank you. Thank you.
See you.
Franzi. Yeah.
And I put my alcohol into the dry.
Yeah. Yeah, I think that it needs to have like the broth already done
Yeah.
and closed. So that you only still.
Well,
The paraffin mucho.
what?
Paraffin.
That part now is missing.
Yeah.
But we still want to put more food, right?
Yeah.
So what are we gonna do? We're just gonna leave that until this is cool?
I think it's better if we close them
Yeah.
and put them in the incubator. We'll bring everything up, and once the food is, maybe even like give it a day.
And then put more food.
Yeah, let me do this one.
Okay. Do we need to film each? No, right? For the small ones, we just need smaller pieces, right? For each dissection.
Sorry, I cannot do this.
Yeah.
We need to close this now.
But do we need for each of them one? No, right? For the small ones, we just need
The very small ones? Okay. Stupid. I shouldn't have taken the gloves. I don't know why I took the gloves. You can stop the recording. Hold in hands.